And I think this one is part of the assignment. So I don't know, is this one different data for everybody, or everybody has the same data for this one, or you don't know? I don't care.
It will randomize.
It will randomize? Okay, so there's nothing wrong if we do it. So you see over here that they don't give you their mass, they give you their weight, no? So 20 WB, it doesn't matter, I'm just gonna write down the equations, but I just wanna know what are the unknowns and the known values. So 10 pounds, all the moment of inertia of the pulleys are the same. So I sub C, I sub B equal to I is equal to 0.022. Didn't we do something like that I told you to move that we had inches and feet, and I told you to move this one into inches? Yeah, when we did want something like that because I remember that. And T equals to 15 pounds. So again, do the figure. All right, so let's see. I'm leaving that figure because sorry, you won't have my hand in front of it. Okay. Oh, I did it wrong. Okay, I need to restart. Okay. And CT equal to 15. 20. .22 and R. Okay, both pulleys are the same. Okay, determine the acceleration of A. All right, so I'll show you what I have. Okay, so that's the figure that I have over here. And if you want, we can solve it with, we can even try to solve it with math. That way, you can probably teach me something. Here, the only thing we need to be careful is that the units for this one were slugs per foot square, which probably we're gonna have to change the units, no? Okay, but what I'm interested in is not that part, it's not the numerical part, it's what we're gonna be doing next. So you need to find the acceleration of A, and you know the forces. So what is the strategy? What is the first step? So body diagrams. So you need to do a diagram for each rigid body, unless you can combine them. So over here, how many rigid bodies do you have? There's really 3, but can you combine B and A? Yes. Okay. So we can do over here. So let's do the first one. Will be here combining. This will be A plus B. So if I do that, and remember, what do I want to see? I want to see 2, no? Because this will be used for the left-hand side of the equation. This one will be used for the right-hand side of the equation. All right. So this will be here point B. But really this point B here will be also be point A, no? Okay, if you want it to be very accurate, then we'll see how we call it. I know this is small, but I don't mind. Can you see or not? Okay. So if we combine these two together, what are we doing really? This will be, the weight will be combined, and we can combine it. Why? Because what will be the motion of A? Point A will have the same motion as point B, no? The only thing that is adding is the weight, correct? Okay. So do we have other forces acting over here? What do you mean, no?
Tension on the left and tension on the right.
Okay, will it be the same or different? Okay, if they are the same, what is the assumption you are making?
Well, if they're the same.
Correct. If they are the same, it will not be moving, it will be statics, no? But if it's more, in order for this to move, those two tension needs to be different. Yep. So T1, T2. So this will take care of the forces and so on. Anything else? Okay. Now, so this side is forces and moments. This side will be inertia effects. So you want effects due to the motion. So what are you going to have over here? You're going to have I sub A. Oh, what is I sub B? So it should be I sub B and I sub C, I guess. Not A and B. So it should be, let's say, I alpha. But it should be alpha sub B, no? The pulley B. Here they are the same radius, so it's not going to affect, but if it was different radiuses, it would change, no? And then this will also, what would you have over here? You will have M sub A plus M sub B, A, no? And let's say this will be acceleration of A or B, no? Since it's what we need to find, correct? I mean, you can do the other one here if you want, also the other one over here, but is it any motion on the sideway? No, so it will be zero, no? Okay, so, but if you want, you can put it, and math will give you that is zero. So this would be for the A and B. Now you need to do another figure. So this is the important part. This is the most difficult part. This is what you don't need to rush. So now for C, what are you going to have at C? So let's start here by T. What else are you going to have? Okay, T3 on the other side. And what else? Okay, you have the weight here of WC, no? Oh, I think I called it A and B, but I think I wasn't paying attention. So, what it should be called here is B and C. You see, A is 20, B and C is 10. I was going too fast. I sub B equal I sub C, T, and that's it, no? So, yeah. So this is point C, this is point C. So I add over here the weight of C. What else do I need to add?
T2.
T2, but it should be what? On the opposite direction than this one, no? Action reaction, no? So going up, T2. One we can put here R, might be needed later, R. Now, what type of motion? So what type of motion that pulley have? Translation and rotation, no? What about this one?
One is T2.
Oh, should be going down, sorry. I say action reaction, but it should be going down, yes. Thank you. So this is moving, translation and rotation. So now over here, what are you going to have? This should be what now? M sub C, acceleration of point C, no? Of the CG of that one. And then you're going to have over here what? I alpha sub C. This is the most important part. Because if you have this incorrect, what's going to happen?
Yeah.
Everything else is incorrect, no? So this is the important part. This is the place where you're going to show me that you understand the problem. Okay, if you ask me out of the 8 points, 5 will be from the feedback diagram. No? Okay, so this is critical. So, all right, so now you come here, what do you do? What do you do next? Write kinetic equations. What are the two kinetics equations that we're going to be using? And summation of the moments. I know in this case will not be an issue, but what is the stuff that I told you? Always take the moments about the same point that you take the moments of inertia, no? Same point, okay? All right, so let's start by, so this will be C. Let's start by A plus B. I have to go to the next page, but it doesn't matter. So you need to look at the figure. If there is no figure, we cannot write down the equation. So in this case, let's just say we write down, and let's use the common coordinate system. Let's not come up with anything new. Let's use X and Y, okay? So we need to do what? Summation on the Y, no? Yeah. So this will give us what? T1 plus T2, everything from the figure, minus WA plus WB. I mean, I wrote it under this form, but you can put minus if you want. And this should be equal to what? I look at the right side, so you want to use M will be equal to what? So W is equal to mg, no? Okay, so that M will be weight divided by G, so we have what? 1 over G WA WB times the acceleration of which point? A, which is what we need to find. So here you don't think too much. You write down the equation, and what do you say? Equation 1. All right? Remember, procedure. Okay. Can we use here the summation of forces on the X? 0 equal to 0, no? Okay, so useless. So the next thing we can do is what? Take moments. About which point are we going to take moments? Okay, we know the moments of inertia about point B and C. So let's take B or A. It would be the same thing. Let's say B, since we know B. And this will be B and alpha sub B, no? I mean, B is the same thing as A, but just because we wrote I sub B. I'm going to write now this, we know I sub B equal to I, but just for this. Okay, so let's go over here. All right, so T2 will be put in a positive moment, correct? T1 negative, I don't know if this is the best way to write it down or not, but I want to write it down this way. So we could write this as T2 minus T1, no? Times R, correct? All right. Anything else creating a moment over here? No. And this should be equal to what? I sub B that we know is whatever, 0.022 times alpha B. This should be equation 2. Okay, remember that in class is the time to ask as many questions as you want. All right. Now we do the same thing for the C, okay? So again, I need the figure, no figure, no equations. So for C, I'm going to write down summation of forces on the Y, if you want again, which this time is going to give us what? T3 plus T minus T2 minus WC. And this one is a lot. So 1, 2, 3, 4. And this should be equal to what? Correct. So WC over G now times acceleration of C. And this should be our equation 3. All right, one more. we're gonna write down summation of the moments about which point? C equal I sub C alpha C. Counterclockwise. So what would be the equation over here? The other way around, no? T minus T3 times R equal I sub C alpha sub C. Okay, here don't panic, okay? You're just writing equations. This is the most, these two out of the 8 points are probably, I don't know, because we need the other equations, but 4 plus 2, 6, okay? No, something like that. All right, so now what is the step you need to do? Any question about these steps? Yes?
How did you tell that T is positive, T3 is negative?
Okay, what do we do? What is considered a positive moment? Counterclockwise is positive, clockwise is negative. Same thing we did for the A plus B, okay?
Right, so we're going in this way.
Correct. I use, you see over here, I put positive counterclockwise.
Yep.
If you don't put this, it's fine, but I'm always going to take the normal sign convention, which is counterclockwise is positive. Okay. All right. Good question. All right. So I come here. What is at this point? What do you need to do? Correct. So you know you have 4 equations. That's the easiest part. Unknowns, probably the best thing is to count them. So from the first equation, what are the unknowns?
T1, T2,
T1, T2,
A sub A.
the acceleration of A. Perfect. From equation 2,
Angular acceleration.
correct, perfect. Then from 3, T3 and AC. And from 4, nothing new.
Angular acceleration.
Yeah, alpha C. Yeah, correct, alpha C. So now you count them. 1, 2, 3, 4, 5, 6, 7. So what does that mean? We need to find 3 additional equations, no? Where are we going to go get those additional equations? Perfect, we go to kinematics. Okay, so maybe here, let me redo a very quick figure. It's not going to be good, I know, but let me try. Basically, that's what we have, no? Yeah. So let's say this is A, this is C. All right. So let's start giving new names. So what do we know about, oops, I did something wrong here, okay? This is not attached to the wall. Here is only T, no? All right? Attached. It's this side which is attached to the wall. So what do we know about this point here and this point here? These are instantaneous center, no? Because what is the velocity of the wall? 0. So this looks like this pulley here will be like rolling on top of this string, no? Yeah, and the same thing for this one. All right. So I think I always call this one. So I mean, I can call it whatever you want, but let's say let's call this one P, and this one you want to call it what? Q. Is that okay? Okay. Whatever you want, okay? That's probably okay. And then we have to call this point here. This point here, you want to call it what? Can I call this one C bar or C prime? Because you agree that this point here we have to move the same velocity and same acceleration as this one, no? So that you want to call it C or C prime?
C prime. We already have a C.
Yeah, correct. But I mean, so basically we can say C prime equal to C, no? indirectly, no? I agree. I mean, when you go, it's better to start from one end to the other one. So, like always, we start from one point that we know and we move to the other one, no? So, something you didn't say in this point, but probably what is the assumption you're going to do? If it's not there, you're always going to do it. Initially arrest, which means this will be 0, no? Okay, so what do we need to find? We need to find the acceleration of A. So probably we need to find the acceleration of A because that's in equation 1, no? Okay. But so that's the unknown we need to find. That's probably we don't need to change anything. So what can we do then? I mean, generally the strategy when you need to find relation between is to start from one point that you know everything and then try to find the velocity of the acceleration of one point from two different locations, no? Remember the bars? And that is the point in common between the two bars. If these were two bars, what is the point in common of the two bars? Point C, no? C or C prime. So what can we do? What about finding the acceleration of C, let's say from point Q, and find the acceleration of C or C prime from point P, no? Yeah? Okay, so here be careful. So which one you want to do first? Okay. Let's say acceleration of, let's start at the top one, acceleration of C from point Q. This one is a little bit easier. So it will be acceleration of Q plus alpha of which gear? C plus S of C with respect to Q minus omega squared C if you want, S of C with respect to Q. Okay, what's happening here? We're going from here to the center of this pulley. So then what's happening? What can I do here? Okay, so they cancel each other. I hope it's clear. Okay, all right. So cancel each other. So basically, we're gonna have acceleration of C equal to I J K of what? 0, 0, alpha C. And then what is the position of C with respect to Q? I'll do everything symbolic, okay? So you can follow it. So this will give you acceleration of C. If you do the cross product, what do you get? 0, which makes sense, no? There's no motion. Or alpha C, okay? So basically from here, you can get maybe one equation, let's say acceleration of C equal to R alpha C. And this can be one equation because this you can substitute into equation 3, no? Yeah? So let's say this could be our equation maybe, I mean, let's not put numbers yet. So this way, and then at the end we figure out. So let's do it that way for now. But it's probably going to be 4. Now, the other thing we want to do is find the acceleration now of C or C prime from point P, no? So this one's going to be a bit more involved, I mean, or not, but acceleration of C prime from point P will be acceleration of P plus alpha of A plus S of what? C prime with respect to P minus omega A squared S of C prime with respect to P. Yeah, I think, so now what's going to happen with these two terms? Do they cancel out? right, let's write it down. So in here, remember we say that when we did the study, when we had the study, we say something roll in here, no? Remember? It cancels the component that goes from the ground to the center, which is what we did over here, no? But here, is it going to the ground? If you want from point P to the center, is it going to all the way to the other side? I mean, it's going to be zero because it's zero, no? But you see, if it was not zero, it would be different, no? Do you see what I'm saying here?
So it wasn't being released from rest.
Correct. It will not. You could not cancel these two terms, no? In this case, it is, but I mean, I cannot explain it quick, but all right. So if you ask me on the exam, what I would like to see is actually you do this, okay? So you show me that you have a great understanding. You do A of P plus I JK of 0, 0. What is this? Alpha A. What is the position of C prime with respect to P? 2R 0, 0. And then here you're going to have minus omega squared A of what? R. Let me do R plus R, no? 0. Correct. So something like that. And then here you will do like this will really cancel just 1. And you put over here 0. And then you show me that you are mastering this. So anyway, from here we'll get then acceleration of C prime equal to acceleration of C. This will give us what? 0
and 2R.
2R alpha A, or this will give you acceleration of C prime equal acceleration of C equals to 2R alpha A. Okay, now what can I do? Why are we doing all this stuff? So we're going to equate this one to this one, no? All right. So really, I mean, just put numbers if you want after while I was waiting. Let's say it would be equation 4, 5, oh, sorry, no. 5 and 6.
Count AC, it was AC prime as a 7.
You can what? Yes, I mean, C prime is the same as a C, no? Because you agree that this would be attached to the same string. So there's no way that the string moves with different accelerations, no? Yeah? Okay? It was just like if it was a bar, no? You think about it? Okay, so now we equate, so let's say here, equate and 6, so it will give you A of C equals to R alpha C equals to 2R alpha A, or I can just write here, whatever, alpha C will be equal to 2 alpha A. And this should be our equation 7. So now what do we have? 7 equation. 7 unknowns. So what can we do? Solve. Okay, so let's do it together. That way you can have me. Which one? What do you want to use? MATLAB? MATLAB? I think you're more familiar with MATLAB. So I like Maple because you can put symbolic stuff. But I think MATLAB got a lot better for us, for everything. So you have to help me here. I mean, any question about what we have done? Okay. All right, so let me close this stuff over here. I don't use it, but if you use it, you can leave it open. So
Yeah, new script.
new script you want to use?
Well, you can run it in command line, but it's a pain.
To what?
You can do it in command line, but it's a pain.
Okay, so let's use script. Whatever you tell me to do. Okay?
Oh, no, you're right. It's good.
Live new script. It's fine. Okay. I'm not really familiar with this.
A regular script would be fine.
Can I close this down here?
Yeah.
I mean, we'll figure it out, okay? So over here, let's put the variables that we know first. So it looks like WA. So I always do here clear all. I don't know if there's one with this. Clear all CLC, okay? So you clear all the screen, you clear everything. And then I put the variables, let's say, so I put here in order that I wrote them down. So T equal to 15. The weight of A is 20. Weight of B is 10. Weight of C is 10. Okay? G, so let's be careful here. So G, how much will be G? As 32.2 will be the units. That would be fit, but you want to move everything to inches? Or you want to move the no, it's fine. We can move then the, yeah, we can just move the radius to fit, no?
Yeah.
Okay.
Everything else.
Yeah, so 32.2.
Yeah.
All right, whatever you done, okay? R, so we need to be careful then with R, but R capital instead of lowercase r. It was 4 inches, so we do that in feet would be what? 1/3 of 4 divided by 12, no? Yeah? Do we need anything else for the, okay.
We need the eyes, right? Moments of inertia.
Yeah.
Yes, correct. You have I sub B equal to 0.022. I sub C equal I sub B, no? All right, okay, so now let's write down the equations. All right, so let's do equation 1. Oh, I know you can do that differently. Let's try, because I never tried this one. I don't know how to do it, the truth, but equation 1, can you do this? Would be, let's say, T1. Oh, I need to put first the symbolic. So what would be, all the unknowns that we have are what? So let's say T1, T2, T3.
Alpha A.
How you want to call alpha A? So we just want to spell alpha A.
Alpha underscore A.
Can you do that? So this way or lowercase a?
That should work.
That should work, okay. And then we have,
If you want to do a little faster, right, you just do A underscore A and A underscore B.
it's fine. And this one should be, what do you use? A or B or C? No, this one actually we use B, no? Instead of A. So B and C. We need 7. What else am I missing here?
Acceleration of A.
So acceleration of A, we can do this maybe, and acceleration of C, can we do this?
Yeah.
All right. Okay, so now I never done this this way. Maybe you can help me here. So T1, can we do? So equation 1 should be T1 plus T2.
I think it's just 1 equals.
It's 1 equals, you set it equal to something else. It's
Okay, so you see it. Thank you so much. So T1 plus T2 minus WA plus WB. I'm just writing the equation as I have them over here. So now I do equal 1 divided by G times WA. Oh, but what do you have? Oh, yeah, plus WB. I use a Q instead of a G. You are correct. G. So equation 1, no? I about this, or what's going to show up. Now we do equation 2. What was equation 2?
T2 minus T1 times that
T2 minus T1 times R
equals
equal I, how do we do the IB times alpha B. Okay, equation 3
T2
is
T3
T3
plus T minus T2
T3 plus T minus T2 minus the weight of C equal the weight of C divided by G times A of C.
Do you need to put parentheses between the G?
We're over here in here.
Yeah, on that equation, the C over G needs to be parentheses are the ones that multiply G by AC on the bottom. And
No, I don't think so. I think this would do W divided by G and they will multiply everything.
well,
But we'll check, okay?
it doesn't follow an operation, so multiply them with that.
No, but then
So if we put G times AC in parentheses.
yeah, for example, let's say
Put W over G.
okay, I mean, let's try it. Let's say you want to do W divided by G and then divided by variable M. Okay,
Right.
so the way Mata will do it, you would do like WC divided, sorry, C divided by G, you will do the division of that one divided by M. It's not going to combine the two at the bottom. So for example, okay, what is 1/4? It will be 1 divided by 2 divided by 2, no? This gives us 1/4. So that makes sense. So we can't leave it as it is, I think. I mean, if you want to put the parentheses, we'll put the parentheses, okay? We're not going to fight over 2 parentheses. All right? That's what you're saying, no?
I'm sure it works either way.
It works either way. That's what I'm saying. So it's completely fine, whatever you want to do. So equation 4 is what? I'm just coming from what we did. So it will be T minus T3 times R equals IC alpha C, no? All right. Equation 5. Oops. Equation 5 that we have will be,
AC equals
okay, so it's A sub C equal
R alpha C.
R times alpha C. Equation 6 equal
AC prime equals AC.
so
That's really.
fine, just put it here equal to R times, no, 2R, no? 2 times R times alpha A, and AQ7 is what?
Isn't AC just R alpha C?
AC, I don't know, I
We
wasn't.
already have AC prime.
AC equal R alpha C, then one I have AC equal to 2R alpha A. Did I do that wrong over here? Or alpha B? It's,
No, you're fine.
no, but that should be alpha B.
Yeah.
It's not alpha because we don't have an alpha A.
Right.
We have B and C. So let's go back then to the equations. So what we're saying is that really this one here should be a B, no? On equation 7. And on equation 6, this is also a B. Because remember we took here A, B. So, okay, so this should be alpha B. And equation 7 is what? Oops.
C equals 2 alpha B.
alpha C equals 2 times alpha B. Okay, so now I don't know, maybe you're probably better than I am. Yes.
Equation 6 is equal to semicolon.
Yeah, thank you. Okay, so now I'm not that familiar with this, so I don't know. What do we do?
Solve.
Can I just put the solve or do we need to put the variables? So we do this or I don't know.
You could set up as a matrix, but I always just use
Okay, just solve.
solve.
All right, so solve, then parentheses. Oh, okay, that's not what I was trying to do. Okay, I don't know what it's doing.
Oh, I think we use that one. I just do EQM solve.
Yeah, I mean it's. How can I remove this stuff? What do I do to remove that? Okay, I don't know what I've done, but okay. So here we got solve, and now that's the only thing I don't know how to do. I know how to do it in. So how do I put the list? Do I need to put it in semicolons or? I tell you, I've never done it in MATLAB, so. Okay, this. EQ5, EQ6, EQ7. Already smart and stuff. What's to do this way? And now here we can even say, I guess, variables. We could do the same thing, kind of the same thing, no? Yeah. Maybe we can do this. I guess it will work just with the space, but let's put parentheses. I don't think it cares if it's a row or column, but maybe not. Okay, now is when you need to do letter prayer. What was this problem? 1852, something like that? And now to run it, run away. Okay, what happens is that this is when it goes symbolic, is a pain. So maybe what you need to do here is the, I know this one because I know I did it the other day, but I don't know if he's going to do it. VP81, let's see. Let's see, VPA solves. Well, so here you don't think here you could, so you put the variables over here, no?
Mhm.
I mean, anyway, you take your calculator and you type this, okay? What can I say? This should be a way to do it with the VPA, but I've done it, but
Yeah, I should really do this.
do you think maybe this would work? I don't know. I think it might be redundant, but no, but then now this is going to work. And now you can just put here VPA, for example, T1, and it should work. It gives you the value. So now you can come over here and type if you want to have the values VPA, whatever, T1, and so on and so on, and you don't have to do the. All right. It's not catastrophic to take your, you don't even need to take your calculator, but. So VPA, we only need VPA AC, no? So forget about it. So then let's delete this one. So if you want, you can put them. VPA A sub A. That's not good. 0? No, because that part is capital A, no? Is that what the variable?
That's one of the variables. Are we sure that it was supposed to be AC equals alpha or 2 alpha B not A? Something like that.
Let's check. This one should be what? Maybe it's here. The problem is
I think it's 5 or 6.
equation 6 should be. So equation 6 is when we're going from point P. So that should be alpha B.
Should be just alpha C equals 2 or alpha A.
AC is not in that. Not necessarily.
Yeah, alpha A is not because we changed alpha A by alpha B, no?
Well, no.
Acceleration.
Like, the acceleration rate is not in.
Oh, because we didn't put it here. On the first equation, see? Times A, thank you. Oh, A, we forgot that one, no? Yeah?
Yeah.
You see, that way we can check our work. Now. So I don't know what I've done here, but it basically will be 10.733. This was the one from before, I guess, no? And he's giving you the values. Oh, this is from before, so it's not deleting anything.
Go up to the top. It's clear.
But why didn't clear when I say execute everything run? Because it was over there.
It only does it one section. Of each section.
Oh, it does it per section. Okay, I don't know.
It's not.
So then, so how can I run everything?
You do it alone.
That's what I want to use.
But since it's a live script, it doesn't do it. Yeah, you could just delete the equation. It's like
Okay, I look.
not be like this.
This one here.
No, that one.
This one.
No, up there. The big bold one that says equation.
Yeah, and I don't use the script, so. Or whatever. I don't know why it's putting the AC equal to 0 here, but where is that one coming from? But anyway, this is what you get, okay? So just resuming here the video, I had to do a little change for one extra equation. So I hope you have it.